Hello everyone, this is Zahid Bashir. Today I am going to discuss two group mean comparison. I welcome the participant of this training. So what we are going to discuss today, let me show you. This is intermediate level of the training. It is 15th day till we started this training for SPSS. Today is 28th March 2024. Time is 9 p.m. to 9:40 p.m. And myself, Zahid Bashir, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. So, what we have covered till today, these are the contents that we have covered, and I have highlighted these contents with yellow color. And at present, we have covered single group mean comparison till yesterday under the topic of mean group comparison. So what we need to cover today, we are going to cover the two group mean comparison as our next topic, two group mean comparison. And after that, we will cover more than two group mean comparison. These are some of the topics which are remaining, and I am hopeful that I will cover these topics till 30th day of our training. So what we are going to cover today, today we will cover two group mean comparison for our analysis. So let me start. What is two group mean comparison? In statistical analysis, a two-group mean comparison typically refers to the comparison of mean between two different groups. So when there are two different groups, you are going to discuss the mean comparison between two different groups. So this analysis aims to determine whether there is a statistically significant difference between the mean of two independent groups. So always remember that we are dealing with two independent groups in case of two group mean comparison. Previously, we were discussing one group with either we are comparing the mean of that group with some standard mean, or we are comparing the mean of that group with the data that we have collected in different point in time. But this time we are basically comparing the mean of two different independent groups. So this type of comparison is common in various fields, including social sciences, medicine, and business. So what do we mean by independent groups? So two independent groups refers to two set of observation or entities that are distinct and unrelated to each other. Always remember they are not related to each other. They are independent from each other. So in the context of particular study or analysis, the term independent implies that the measurement or characteristic of one group are not influenced by or related to the measurement of other groups. So in statistical terms, the group are considered independent when the values in one group are not systematically linked to the values of the other groups. So always remember the values of both groups are independent to each other. They do not depend on each other. That is why they are called independent groups. So what are the examples of two different groups in different fields? How we can compare means of two groups in different fields. For example, in medicine and healthcare, we may be interested in comparing the effectiveness of two different medicine in reducing blood pressure. So two different medicine, it means the data related to two different medicine would be different. They do not related to each other. So how they are effective in reducing the blood pressure uh, in the field of medicine. So how would we apply this concept? So we need to determine if there is a significant difference in the mean blood pressure reduction between patients treated with medicine A and those treated with medicine B. So there are two different types of groups of patients that are treated either by medicine A or either by medicine B. So, what would be the difference between their results, or whether there is a statistical difference between the blood pressure reduction between these two groups or not? The second circumstances would be from the educational domain. We may be interested in assessing the impact of two teaching method on students' exam scores. So compare the mean exam score of students who receive teaching method X and with those who receive teaching method Y to identify the more effective approach. So we will create two different groups of students, one who is receiving the teaching method A and one who is receiving the teaching method B, and we will find out whether the exam score of the student was better in teaching method A or it is better in teaching method B, and whether there is a significance difference between both method or not. Similarly, in psychology domain, we may be interested in finding out, investigating the impact of two therapy approaches on reducing anxiety levels. Mm, we can do it by comparing the mean anxiety scores of individual who underwent therapy A with those who underwent therapy B to determine the more effective intervention. In the same way, if you are interested in finance and economics, you may be interested in assessing the impact of two investment strategies on portfolio return. So we can compare the mean returns of portfolio following investment strategy A with those following investment strategy B to identify the more profitable approach. In the same way, if we are interested in market research, we may be interested in analyzing the effectiveness of two advertising strategy in generating sales. So we can compare the mean sale figure for product promoted using strategy A versus strategy B to understand which strategy is more successful. And last but not the least is environmental study. We may be interested in evaluating the effectiveness of two pollution control method in reducing air pollution. So we can compare the mean levels of air pollutants in areas where control method X was applied versus the control method Y to assess their relative effectiveness. So these are some of the examples where you can understand how the two group mean comparison works. So what are the categories of two group mean comparison? Uh, Today we are going to discuss the normal data with equal variance. This is the first case that you need to understand when you have normal data. So we are going to use independent sample t-test when we have normal data with equal variance. The other cases are normal data with not equal variance and the not normal data when we are going to use the Mann-Whitney test. If I summarize these instances with some more reasonable justifications, you need to understand, first of all, what are the steps required using SPSS for two group mean comparison. First of all, you need to check the normality of the data. Then you need to decide which test is appropriate based on normality. Then you need to compare your mean based on the appropriate test selected on second step. So what is the procedure that we are going to follow? First of all, we need to test the normality of the data. Go to analyze, go to non-parametric test, go to legacy dialog, and go to one sample KS. So I need to put the sample data into test variable list and press OK. It will let me know if the asymptotic sig value is greater than 5%, we will consider this type of data as normal. And if the data is normal, it means we need to use parametric test, which is independent sample t-test. So in case of independent simple t-test, we need to verify two further considerations. The first one is the equal variance assumptions. If the live-in test indicates a value greater than 5%, it means an equal variance assumptions would be applied here. But if equal variance assumptions or the Levin test indicates a value less than 5%, it means here unequal variance is assumed. So always remember, when your parametric test independent sample t-test is approved, you need to see whether your equal variance is assumed here or unequal variance is assumed. If equal variance assumed, you need to see Levin test value. It should be greater than 0.05. But if you assume unequal variance, the Levin test will be showing a value less than 5%. In other cases, if your asymptotic sig value is less than 5%, your data would be considered not normal. In that case, you are going to use Mann-Whitney U test. This is the test which basically supports the non-parametric procedure. So in that case, you don't need to go for further consideration like we have done in parametric test procedure. So what we need to do, we go to case number one, normal data with equal variances. So when your data fulfill the normality assumption as well as equal variance assumption, the test appropriate for two group mean comparison of such data would be independent sample t-test. So you need to fulfill two conditions, not only the normality, but you also need to verify that equal variance assumptions would also need to be fulfilled here. So in order to correctly confirm your independent sample t-test, you need to verify two conditions. First is normality and the second is equal variance. So what is independent sample t-test? The independent sample t-test is a statistical method used to compare the mean of two independent groups for a one continuous variable to determine if there is a statistically significant difference between them. This test is applicable when the observation in one group are not related or paired with the observation in the other group. Always remember that observation of two groups should not be same. So what we need to do, we need to create a one continuous variable here. I will let you know how we can create it. If we have two independent groups, how can we create one continuous variable based on these two groups? Because in order to test the normality, we need to test the normality using a representative group, which represent both of those groups. So I need to create a one continuous variable here. So this test is applicable when the observation in one group are not related or paired with the observation in the other group. The independent sample t-test is widely used in various fields to compare the mean of the two distinct groups, such as comparing the test score of students from the two different schools or evaluating the effectiveness of two different medical treatments. So let me show you the procedure. There are some assumptions. First, you need to know what are the assumptions of applying the independent t-test. The first assumption is that observation in each group must be independent to each other. They should not be dependent on each other. They should be independent. This means that the value of one observation is not influenced or related to the value of other observation in both groups. So they both must be independent. The second is the normality. Your data should be normal. The population from which the sample are drawn should be approximately normally distributed. So if the sample size are larger, typically n greater than 30, the central limit theorem often allows for the assumption of normality to be met. So we need to apply this condition. If we have the observation, the number of observation greater than 30, it means we are assuming that our data is normal. In that case, we don't need to check the normality. So always remember, if your number of observation are greater than 30, then you don't need to check the normality. But if your number of observation are less than 30, it means you need to verify whether your data is normal or not, or whether your distribution of the data is showing the normality or not. So The third condition is homogeneity of variance. Your variance should be homogeneous. That is another condition. Then data type and sampling. The data for dependent variable needs to be continuous. So we need to use a continuous variable here. And the last is the comparison of common continuous variable with two different categorical variable. I will let you know this condition during the test procedure. So what we need to do, example of scenario with independent t-test. There are a lot of scenarios I have discussed already, but as a guideline, you can see them again. So there are a lot of conditions I have discussed. These are some of the conditions that are applicable with t-testing application. You can pause the recorded session if you want to read these in a detailed format. So let we discuss the example one. An analyst at a departmental store wants to evaluate a recent credit card promotion. To this end, 500 card holders were randomly selected. This is the sample size. If you remember, I have told you that your sample size should be greater than 30. If it is greater than 30, it means your data is normal or it is normally distributed. In this case, we don't need to check the normality because our data is already normal. It is basically assumed that the data is normal because it is greater than 30 observation. So 500 card holder were randomly selected. Half received an ad promoting at a reduced interest rate on purchase made over the next 3 months, and half received a standard seasonal ad. So there are some credit card holder and they received a credit card promotion deal. Half of them received reduced interest rate on purchases made over the next 3 months, and half received standard seasonal ad. So what is our requirement of study? Does a credit card promotion offering a reduced interest rate on purchases for the next 3 months result in statistically significantly different in spending behavior compared to standard ad amount randomly selected card holder at the departmental store? So we need to understand that there are two categories of card holder. One who received promotional ad at reduced interest rate, and the one who received the standard seasonal ad. They didn't get any interest rate reduction. So is there any significance difference in their spending behavior? Whether the people who receive reduced interest rate on their card, whether their spending is more, whether they are more spending as compared to the other card holders who did not receive any kind of promotion here. So we need to identify this. So how can we do it? We just need to develop the hypothesis. There is no statistically significant difference in spending behavior between card holder with ad promotion, group 1, and those who receive standard seasonal ad, group 2. So we assume that there is no statistically significant difference in their spending behavior. While our alternative hypothesis would be there is statistically significant difference in spending behavior between card holder with ad promotion and those who receive the standard ad. So this is basically the statistical formation of the hypothesis. Mu1 is equal to mu2. It means there is no significant difference. They are equal actually. And in case of alternative hypothesis, we assume that they are different. They are statistically different. They are not equal. So this is basically the statistical justification. So these are the steps that we are going to apply. As a first step, we need to check the normality. But remember, if your sample size is greater than 30, then you don't need to check the normality. Although I have checked the normality here through the procedure that we are using previously. We go to analyze, we go to non-parametric tests, we go to legacy dialogues, and we check for one sample KF. And here we have choose spending during promotional period as a variable of our study. So we put that spending into our testing variable, and then what we have done, we have find out one sample KS value, which is greater than 5%. It means the data is normal. Although we don't need to check this procedure because our sample size is greater than 30. So we don't need to check this procedure. We can already decide that we need to use the one sample test, one sample in independent sample t-test. So interpretation of normality test, since the level of significance is equal to 0.200, which is greater than 0.05, therefore the normality assumption is fulfilled. So decision is what? As per the data is normal, therefore independent sample t-test will be used for testing the hypothesis. However, we additionally need to check for equality of variance. So we can also write here, as the sample size is greater than 30, therefore according to central limit theorem, our data is approximately null. You can also write here. Let me write here for your consideration, as the sample size is greater than 30. Therefore, as per the central limit theorem concept, our data is already approximately normal. All right. So this is another explanation of what we have done here, because our sample size is greater than 30, and in our case it is more than 500. So we don't need to test the normality procedure here. We can additionally give this specification for deciding that we are going to use independent sample t-test. While our other consideration is we need to check the equality of variance too. So first of all, what we need to do here, we go to analyze, go to compare mean, and then you go to independent sample t-test. This is basically the option that we are going to use today. So what you need to do, you need to choose the spending, and you need to put it into the test variable, sorry, grouping variable. You need to put your groups into grouping variable, and you need to put spending into the test variable like this. And then you need to define your groups into two different categories. You need to check what type of categories do you have. You have two categories here. One is standard, and the second is new promotion. So you need to put their values, like you are seeing standard is reflected by 0 and new promotion is reflected by 1. So you need to put it into your defined variable box like this. This is standard ad and this is promotional ad. So you need to click on continue, and then it's okay. You need to click OK, and you will find the results like this. So what you would be going to see in the results, first of all, you need to see the mean. The mean value, if you see here, the card holder with promotional ads are spending more. If you see here, this is new promotional ad with reducing interest rate. So their mean value is greater than the card holder with standard ads. So card holder with promotional ads are spending more on average as compared to the card holder with standard ad here. While if you see the t value, this is the t value. This is showing that it is less than 5%. So it is indicating significance. The next thing, there are two types of variances are assumed. One is equal variance assumed. The second one is equal variance not assumed, because we need to check to in order to validate our result. If you see equal variance assumed row, you can verify here the sig value. It is greater than 5%. This is basically the Levin test for equality of variance. So if this value is greater than 5%, it means your equality of variances assumed is considered here. But if this value is less than 5%, then you will consider that equality of variance is not assumed here. So what you need to do, you need to see the t value and the stick value. There is a significant difference between the average spending of the card holder with standard ads and promotion. So this sig value is greater than 5%. What it indicates, when this value is greater than 0.05, it means there is equal variance between both independent groups. So let me show you the whole procedure here so that you may understand what I am saying here. So this is the data that I have shared with you. You need to open example one data because we are considering example one here for your consideration. This is example one. So you just need to open the example one data. When it is open, I will let you know the procedure. As I have already told you that there are 500 card holders. It means as per our assumptions, if you see previously, I have told you about the assumptions, the normality assumption. The assumption was that if your sample is greater than, if your sample size is greater than 30, it means it is assumed according to central limit theorem, it is assumed that your normality assumption is met, already met. So in our case, as our data set is greater than 30, so we assume that our normality assumption is met. So if you see here, you can find here that we have the data of 500 card holders, which is greater than 30. So it means our normality assumption is already fulfilled. So we need to check this data. If you can see here, there are three columns. One shows the identification. Second is basically 0101, which is basically indicating which person is related to group 1 and which person is related to group 2. And the third one is basically their spending using their cards. So if you see the variable here, the first one is basically the type of their group. So if you open the value box, you will see here 0 and 1. 0 is considered for standard group of card holders and 1 is considered for promotional ad card holder, because there were two groups. If you see in the example, these 500 card holders are representing half of the card holder who are using the promotional ad and half with standard ad. So we have two group of people, 0 with standard and 1 for new promotional ad. So 0, 1 is the coding that we need to put in the group procedure. The second is spending. This is basically the monthly spending. If you see here, it is written, if you open this is their spending. And this spending is basically your continuous variable here. This one is categorical variable, which is represented by insert, while this one is the continuous variable. So in order to check the normality of the data, you need to use the continuous variable. So we go to non-parametric procedure, although we don't need to check the normality, but for your understanding, I am going to put it again. Click OK, and you will see there's asymptotic sig value. It is greater than 5%. So it means this is normal data. So after finalizing that it is normal data, we need to go to the compare mean. we go to the independent sample t-test because both samples are independent from each other. So we need to select this. We need to put our continuous variable, which is spending, in the test variable box. And we need to put the categorical variable, which is basically the type of mail insert receive. We need to put it into group variable. And then we need to define these groups. As we already know that one of the group was represented by 0 and the other group was represented by 1. If you are not sure about this, you can check your variable again. You need to go to here and you need to see the type of variable here. One group is represented by 0 and one is and the other group is represented by 1. So 0 and 1 is the coding scheme here. So we need to use this coding scheme. Compare mean, independent sample t-test, put your continuous variable here, put your categorical variable here, define group. You need to put here 0 and you need to put here 1, whatever the coding was done. So click OK and you will see the result like this. First of all, you need to see the group statistic. If you see here, the card holder with standard promotion, they have the average spending of 1,566.39. In the same way, the card holder with new promotional ad with reduced interest, they have the average spending of 1,637.50. So the card holder with promotional ad, they are spending more on average. In the same way, if you see the independent sample t-test, first of all, you need to see this sig value, this two-tail sig value. This value validates that there is a significance difference between both card holder average value. There is a significance difference because this two-tail value is basically related to this significance difference. So if it is less than 5%, it means there is a significance difference between the average spending of the standard card holder and average spending of new promotional ad card holder. The second thing that you need to see is regarding the equal variance. If this sig value is greater than 5% and t value greater than 1.96, it means equality of variance is sorry, this t value is related with this sig value. You just need to see the sig value, this sig value for equality of variance assumed. So this value, if this value is greater than 5%, it means your data is confirmed for equality of variance. So if you see here, I have identified this procedure for your consideration here in this picture. So this is what I have been explaining. First, you need to see the mean values. Then you see this for there is a significance difference. Then you see the sig value. Because this value is greater than 5%, it means there is equal variance between both independent groups. So because we want to know whether equality of variance is here or not, we need to do this. Now, interpretation of data. How to interpret? The result indicate that there is a significance difference. T498 is equal to 0.2.260. This is the t value. If you see in the previous table, this is the t value, this one. This one in the blue box, if you see here, this value. This is the t value which we are indicating there. So minus 2.260, p is equal to 0.024 in the mean spending of the card hotel with standard ad and with promotional ad. So there is a significance difference because p is less than 5% and t is greater than 1.96. The finding also indicates that card holder with promotional ads are spending more because their mean value was 1637.50 as a mean, and the card holder with standard ads are showing their mean value as 1566.39. So the magnitude of difference in the mean is minus 71.11 with 95 confidence interval ranging from this. How I concluded it if you see here, this is the mean difference. This is the magnitude of mean difference with this confidence interval. So you need to interpret it like this. So this is the interpretation. I hope you have understood. The second thing is ETA square statistic measured by Cohen D showed a small size effect. So if you see, there are some additional statistics here. So this is Cohen D and it is minus 0.202. This is some statistic. I will let you know what does it mean. So this is the interpretation. I hope you have understood this. So what you need to do next, you need to apply the same procedure on example 2 and example 3. So I would read the example 2. We have 12 spider fobs who are uh, spider fobs were people who basically fear from the spiders. So who were exposed to a picture of spider and 12 different spider fobs who were exposed to real life tarantula. Tarantula is basically a very dangerous spider. So there is a group of 12 people who are exposed a picture of spider and 12 people who were given a real life triangular picture. So what is their anxiety level? Is there any difference? So you need to check the same procedure on example 2. The example 2 data is provided here. Similarly, try to find out the same procedure with example 3. So time is going to end. Do you have any question, Miss Hina and Rabia? As the
No,
discussion
sir.
is going to end. So Rabia said no question. Miss Hina, do you have any question?
No, sir.
All right, all right. So let's meet tomorrow for another session on it. So stay blessed. Thank you very much, both of you, for joining for today's meeting. Thank you.